Today in lesson 9.3, we're going to talk about graphing general rational functions. The title of yesterday's was graphing simple rational functions, and simple doesn't mean easy, so don't be like, oh, that was supposed to be the easy part. Simple doesn't mean easy, it just means that yesterday we only had a first power of x in the equation, and today we can have higher powers of x's. So we might see x squareds or x cubes in our equations today. Yesterday's graphs all had the same shape. They were a hyperbola, two diagonal corners, one horizontal asymptote, one vertical asymptote. Today, when we start graphing general rational functions, the possibilities are pretty much endless for what these things can look like, but we'll be graphing them on the calculator, so we won't need to worry about finding all the details of it by hand. We will still have some details to find by hand, though. So this equation is a bit intimidating, to say the least. The general idea is just like yesterday, that we are going to have a fraction equation, something over something. But the difference is that instead of having just a plain x on the top or just a plain x on the bottom, it could be x squareds or x cubes or something like that. So this is just saying, with all of those horrible letters and symbols, that we might have things added and subtracted up on the tops and bottoms that might have x squareds or x cubes. Okay? But it's going to be something over something like it was yesterday. We are going to find three things by hand for each problem. The first thing we're going to find by hand are the x-intercepts. And that is found by setting the numerator equal to 0. So the first thing we're going to look for are x-intercepts, and that is the numerator being 0. Which part is the numerator? The top. So to find our x-intercepts, we're going to set the top equal to 0 and solve. That will tell us where our line should be crossing the x-axis. The second thing we're going to find by hand are vertical asymptotes, and that is where the denominator is 0. That's the same as yesterday. So yesterday, that was the same thing we did to find our vertical asymptotes. Where are we dividing by 0? Because that's a no-no. So that makes our asymptotes. So x-intercepts are setting the top equal to 0. Vertical asymptotes are setting the bottom equal to 0. Our graph can have at most one horizontal asymptote. We can have more than one vertical asymptote. So yesterday we only had one vertical. Today we could have more than one vertical. But horizontal, we will only have one, if any at all. And this is a three-part rule. We are going to look at the degree, which means the highest power on the top and the bottom. If the numerator wins, if the top has a higher power, then there is no horizontal asymptote. So if we've got like an x squared over an x, the top wins, no horizontal asymptote. If the degrees are the same, so like x squared over x squared, or like yesterday, x over x, then our rule is that it's the fraction of the front numbers, like it was yesterday. We took the fraction of those numbers in front of the x's. So even if it's x squared over x squared, that rule is going to be the same. And the third possibility is if the denominator wins, then it's at y equals 0. So if the top wins, there's none. If they tie, they both get to play a part in it, taking those coefficients. If the bottom wins, it's at y equals 0. So we're going to begin by finding three things by hand and then plotting on the calculator to see how that stuff all connects to each other. So the first thing we want to find by hand is the horizontal asymptote, and that's that three-part rule. So for that, we look at the powers of x. What is the power of x on the top? None. There isn't an x on the top. What's the power of x on the bottom? 2. So who wins? The bottom. The bottom has an x squared. The top doesn't even have an x. So if the bottom wins, what's our horizontal? Y equals 0. Oops, wrong writing utensil. So we should, in this graph, have a horizontal asymptote at y equals 0. Vertical asymptotes are found by setting the denominator equal to 0. We did that same thing yesterday, but today we might have squared stuff instead of just a first power of x. So we subtract 1 from each side and take a square root. What happens? Square root of -1. What is that? I. I is imaginary. We can't see imaginary, so for our purposes, we're going to say there are none because we can't draw them. We can't draw imaginary lines. So since we ended up with an imaginary answer, we're going to say there's none. So there are no vertical asymptotes in this graph. X-intercepts are found by setting the top equal to 0. When does 4 equal 0? It doesn't. So that means that there are no x-intercepts. This graph will never cross the x-axis. So to figure out what it looks like, we are going to graph on the calculator. So in our y equals, we'll type in the equation, remembering like yesterday that we need parentheses around that denominator because it has more than one thing going on in it. And then graphing in that standard window. So if you're still in the standard window from yesterday, you don't need to make any changes there. But otherwise, you can always just go zoom and choose zoom standard, and it'll get you right back to the middle. And we get this picture, which we can just sketch in. I am going to find one precise point here. You don't have to, but it looks like the peak is probably happening at a height of 4, which kind of makes sense in the equation, having that 4 on top. Like maybe that comes into play there. And then kind of creates this little bell. That shape of a curve is called a bell curve. So find the first 3 pieces of information by hand and then plot on the calculator to get the general shape. And what you see should hopefully confirm what you found by hand. If you believed that there was a vertical asymptote and you're not seeing one, that means you probably did something wrong in trying to solve that. Okay? For our next example, the 3 things to find by hand, the horizontal asymptotes. Power of x on the top is squared, on the bottom is squared, so they tie. So what's the rule if they tie? 3 over 1. Take the coefficients of those x's. So our horizontal is going to be at y equals 3 over 1, or 3. If the powers of x's are the same, then they both get to play a part, and we take those coefficients and make them a fraction. Verticals are found by setting the denominator equal to 0. So we're going to add 4 to both sides and take a square root. And what do I get? What do I get? What do I get? What do I get?
4. Square root of 4. None. 3 and 1. -2.
Ah! There you go. Put them together, plus or minus 2. Remember, when we take a square root of the equation, we need a plus or minus, because -2 times -2 is also a possibility. So we get 2 vertical asymptotes here. Remember, when you take a square root in an equation, we need that plus or minus. So we actually get 2 vertical asymptotes. Let's try to get kind of a checkerboard looking thing going on here. Lots of different sections. The last thing we need to find by hand are our x-intercepts, and for those we set the top equal to 0. And what do we get? Zero. So we have an x-intercept at x is 0. So we can plot that 1 point then. Okay, so horizontal was found by the fraction of what's in front of the x's, 3 over 1. Vertical is found by setting the denominator equal to 0. Remember, plus or minus when you take a square root. And our x-intercepts are setting the top equal to 0. To figure out how this looks in those spaces, we will graph it on the calculator. I'm going to put parentheses around the top since there's more than one thing there, and parentheses around the bottom. Whoa. And remember, yours may try to connect or not connect. Technically, they should not be connected. Mine is trying to connect some pieces here that don't really belong to be connected. So if yours are separate pieces, that's actually a good thing. Because within these regions, I should have a little hyperbola-like thing up in the upper left and also up in the upper right. And not connected to that, I should have a parabola-type thing down in the middle section with its peak at 0, 0. Okay. We cannot connect the pieces across a vertical asymptote. So don't connect those pieces across where our vertical asymptotes are. Questions? For our next one, horizontal asymptotes, we look at our powers. Who wins? The top, which means what?
Y equals.
There is not one. If the top wins, there is no horizontal asymptote. So since we have an x squared on the top, and at most just an x on the bottom, this one does not have a horizontal asymptote.
How do we know that one?
The highest power on the top is bigger than the highest power on the bottom. So we only consider the biggest power. So on the top we have an x squared at the biggest. At the bottom we have an x at the biggest. And the rule then says that we do not have a horizontal.
So there's.
So I'm not sure what you do with that, like that knowledge then. So the top's bigger than what you do.
It means that we're not going to put any horizontal asymptote into our graph. So before, when we would put that dotted line going through there, we just don't have one to put in there this time.
But if the lower was bigger?
If the lower was bigger, then it would be at y equals 0. And if they're the same, then that's when we take the fraction of what's in front of the x's.
Okay.
So if it's bigger on bottom, it's 0. If it's tied, you do the coefficients. And if it's bigger on top, nothing.
Correct. Yep. Bigger on top is none. Bigger on bottom is 0. If they're the same, then they both get to play a part, and we take the fraction. For verticals, we always find verticals by setting the denominator equal to 0. So what do we get? X equals -4. Our verticals are found by setting the denominator equal to 0. Our x-intercepts are found by setting our numerator equal to 0. We're going to solve this by factoring. What multiplies to be -3 that adds to be -2? -3, and +1. What does that mean our solutions are? 3 and -1. So we get 2 x-intercepts in this one. At 3 and -1.
Wait, we don't check to see which one's right.
They are both right. We will not have extraneous solutions here. They are both true. So this is what we know so far. We have one vertical asymptote in 2 places this thing is going to cross the x-axis. To determine what it's going to look like around all that stuff, we graph on the calculator. Remember to put parentheses around the top because there's definitely more than one thing going on there. Divided by parentheses around the bottom as well.
When you factored, you do the opposite of what you got. I don't remember.
The solutions are the opposites of the factors. Yep. When you solve by factoring, your solutions are the opposites of the factors. All right, so this is what I see, which lines up with what we have so far, that we have that vertical asymptote in, and we have our 2 x-intercepts, but there should always be something existing on both sides of a vertical asymptote. So I'm seeing something over on the right, but I am not seeing anything on the left, and there should be. There should always be something on both sides of a vertical asymptote. What that means is I'm not seeing enough of the picture. So what we're going to do on our calculator is press the zoom button, top center, and choose the choice that we want to zoom out. We want to see more of the picture. When you choose that, it won't change right away. You have to hit enter again, and then it will redraw the graph, showing us more information. So now we can see that there was indeed another piece over on the other side that we just couldn't see before. So we know we have our vertical and our 2 solutions. And it looked something like this at first. But by zooming out, we can see that way down low, we actually have another piece of the picture. So if you only see something happening on one side of a vertical asymptote, you know that you will need to zoom out because you're not seeing everything that there is. Questions?
So we have to zoom back in if we want to get back to normal.
Yes, so for the next problem, instead of just hitting graph, we will need to readjust our zoom again. So first thing to consider, horizontal. Who wins in this one? The bottom, which means what?
0.
Y equals 0. If the power in the bottom is bigger, then we have an asymptote at y equals 0. Vertical, we find by setting the bottom equal to 0. Subtract 1 from both sides and take a square root. And I get an imaginary, and I can't draw imaginary lines, so I don't have any of those. X-intercepts are found by setting the top equal to 0, which just gives x equals 0. So it crosses through right in the middle. Now that means when I first defined an asymptote for you, I kind of lied a little bit. All math teachers do this because it makes it easier the first time you encounter something. But I told you that an asymptote was a line that a graph never crosses. That's not entirely true. It's a line that shapes the ends of the graph. So it can cross over that asymptote anywhere kind of in its middle, but as it moves to the left, it it's going to be shaped by that line. So we should expect it to be shaped by that line at its ends, but in its middle it can kind of do anything it wants. So it's okay that we have a point on the asymptote there. Vertical asymptotes cannot be crossed. I am not lying about that. Vertical asymptotes cannot be crossed, but horizontal ones can.
So what's the point of having it?
They shape the ends of the graph. So they tell us about what the edges of the graph do. So I have x over x squared plus 1. Now in the last problem we zoomed out. I want to go back to normal again. So I'm going to go zoom and choose choice 6 for our standard window again. I can't really see it. I can tell something's happening there, but it's kind of hard to see because it's too little. So similar to the last problem, this time I want to zoom in on it. Once again, you have to press enter one more time for a change to actually occur. And then we can see that it is crossing through the origin, and it kind of has a little bump on each side. But it's following along that asymptote line at its edges. Questions?
How does that shape the cell?
It's following the line. It won't cross over that line at the ends. So as we head out to the right, it's decreasing, but it's never going to decrease past that line. It's just going to keep getting closer to that line. Horizontal asymptote. Who wins? They tie. So what's the rule? Take the fraction of the coefficients, so y equals 2 over 1, or just 2. Vertical asymptote. We set the bottom equal to 0. So I add 1 and take a cubed root. And what do I get? Why not plus or minus 1?
Because it's odd.
Because it's an odd root. So remember, even roots you need plus and minus. So like a square root, we need a plus and minus. Odd roots, we do not. So a cube root, we just get the single value. So we get a vertical asymptote at x is 1. X-intercepts, we set the top equal to 0. So 2x cubed equals 0 means that x is equal to 0. So we know we have one place it's going to cross over the x-axis. Then to get the picture of how it fills in those spaces, we go to our calculator. So I'm going to put parentheses around the top again. Divided by, parentheses around the bottom. On the last problem, we zoomed in. So if I want to go back to normal, I'm going to go zoom, and choice 6 is standard. And we get our picture. This one kind of looks hyperbola-ish. There is a slight difference about it just being a hyperbola. That right where it has that x-intercept, instead of just being nice and smooth, it kind of takes a little bump. But I wouldn't be picky about that in your graph if you didn't happen to notice that. But this one looks the most like our problems yesterday. And that will happen when the powers are the same typically. That will have something that looks the most like our problems from yesterday. Questions?
Did the top right, quarter pipe thing, does that have the little bump in
The top right one does not have the little bump. It just happens at that x-intercept there that we have a little bump.
How do you do the cube root and just anything over?
I know it.
On the calculator, cube root, you could do a power of 1/3, because remember, a root is a fraction power, or in the math menu, there's an option for a cube root.
And then it's fun.
All right, one more example to look at together.
Oh.
Horizontal asymptotes. We're looking at the powers. Who wins? The top wins. Now, there is just a plain x in the top, but we're looking at the power. So we care about the top having a squared and the bottom only having a single. So the top wins, which means there is none. So we only care about the highest power in each of them. For our vertical, we set the denominator equal to 0, which gives us 2. And for our x-intercepts, we set the top equal to 0. And this will need to be factored. What multiplies to -4 that adds to -3? -4 and +1 will multiply to -4 and add to -3. So that gives us solutions of +4 and -1. And these things should be confirmed when you look at your graph. So you should know after doing your graph if you've maybe done something wrong, because if you thought your solutions were somewhere else, then your picture should kind of show you whether you've done things right or wrong. So that's what we know so far. Vertical at 2 and 2 x-intercepts at 4 and -1. No horizontals. So we go to a calculator to graph and fill in the spots. Parentheses around that big numerator. And also parentheses around the denominator. And graph. And what we see does confirm where asymptote should be and where solution should be as we get those two pieces. Questions? Listen very carefully about your homework. For your homework, for problems 11 through 16, the directions ask you to find the x-intercepts and the vertical asymptotes. I am adding to that you need to also tell me the horizontals, but you do not need to graph. Okay? So for problems 11 through 16, do the stuff that we did by hand. But you don't need to graph. The rest of the problems, you can just follow the given directions.